my great pleasure to join this celebration of the 55 years anniversary of the Engineers Association of Peru. And please allow me on behalf of the World Federation of Engineering Organizations, WFEO, to congratulate you heartfully for your success in the past 58 years, and even more success, even more larger success in the years to come, especially in pursuing a true transformative recovery from the COVID-19. So please allow me show this picture at first. And here you see the picture in the front of your building. That picture I took 5 years ago when I visited Peru and attend this Congress held by Peru Association of Engineers. I still remember that visit, and that meeting is a big success. So now let's start my presentation under the title of Protect Human Life from COVID-19 and Build Back Better by using emerging technologies in engineering. You know, the inaugural celebration of the World Engineering Day was planned for the 4th of March, early this year in the UNESCO headquarters. But because of the coronavirus, we have postponed and canceled this big celebration. However, the engineers are standing in the front line of fighting against the virus. On that very day of the first World Engineering Day, the World Federation of Engineering Organization has declared its statement on the COVID-19 situation. And we use the title Engineering Stepping to the Challenge of Coronavirus and Other Threats. So in this statement, we're highlighting the necessity and importance of international collaboration in confronting the virus. We have established a special portal on our website. We called it COVID-19 Information Portal. Here you see the website, the page of the main page of the WFEO website. And if you click here, you get into the portal. This is a special portal we established to help engineers worldwide to fight with the COVID-19. And in this portal, you have, you see here 5 tabs. And the first tab is the COVID-19, the engineers in the medium. And here you can find some examples such as the value of engineering in this fighting with the COVID-19 crisis, and the engineering response to the COVID-19, the tools to understand COVID-19, and engineers supporting continuous learning during the lockdown. This is the first tab. And then you can find the second tab, which shows you the member actions. You see WFU members are actively standing in the front line to fight with this virus. And let's keep the third one. The fourth one highlights the contribution to the medical resolutions. And the last one is a knowledge hub. in this tab, you can find different resources linked to important international organizations such as OECD, the UK Department of Health, the World Organization, the WHO, and so on and so forth, and even Johns Hopkins University to get necessary information about the COVID-19. Now let's go back to the third one. The third tab showcases how to use emerging technology such as big data and artificial intelligence to fight with COVID-19. And these emerging technologies has been widely used for prediction, for diagnosis, and so on and so forth. And here is a very good example that shows you the very first alarm was given by an AI startup company based in Canada on the day of 31st December 2019. And here you see this organization is called Blue Dot, and this company uses the AI-driven algorithm and source the foreign language news reports, animal and plant disease networks, and official proclamations to give its clients advanced warning to avoid the danger zones like Wuhan. And this is really a very great success. They have successfully predicted the outbreak of this new coronavirus in the very early time. That shows how strong the AI and big data can do. And here is another example. It's the monitoring the spread of the virus. And here you see the picture. This is a real picture on the street. And here is the monitored picture using the infrared waves. And you can find certain people with a high temperature, and to isolate these people afterwards. There's a real-time monitoring. And here is an example in diagnosis. And this is a lung CT image. And by machine learning, the AI system can tell the doctor whether it is the abnormal symptom of the lung image, which is suspected to be a affected person by the COVID-19. And this was used in the early time to screen a large number of patients to quickly find out the most possible infected people. And here is another example used in Israel, and they use diagnostic robots to assess and monitoring the virus. Now, the AI and big data is also widely used in the drug development to help doctors, scientists to quickly find the possible effective drug against COVID-19. Here's an example in Korea. There's a company in Korea using the AI system and big data to screen candidate compounds that takes a a very quick way to find possible effective compounds to developing the drugs against COVID-19. And here you see some medical equipment which has been already used in the hospital worldwide to help doctors to treat the patient in the isolated zone of these affected patient. And here, the AI tools is also widely used for the public science literacy to increase the awareness of the public to this new coronavirus disease. And here you see a IBM app on the handset, and which assists the citizen automatically to answer the frequently asked questions. And you can also reporting your questions to the crowd and got a specific answer from the crowd, assisted by Watson Assistant. That's the IBM system. Here, please allow me to cite from the paper, the unedited paper of the United Nations Secretary General. This report is going to release on July to the high-level political forum. In this draft report, the Secretary General said, while this crisis is improving progress towards the Sustainable Development Goals, it also makes the achievement all the more urgent and necessary. Moving forward, it is essential that recent gains are protected as much as possible, and a truly transformative recovery from COVID-19 is pursued. One that reduces risks to future crises and bring much closer the inclusive and sustainable development required to meet the goals of the 2030 Agenda and the Paris Agreement to climate change. It will require a surge in international cooperation and multilateralism. So actually, the World Federation of Engineering Organizations, WFEO, has just released a position paper last Friday. That is a World Environmental Day, and to call international collaboration to meet the challenge of climate change and to build back better with the joint efforts of our engineers worldwide. And here, I would like to show you a new model for integrated implementation of the Sustainable Development Goals. This model is proposed by the Global Sustainable Development Report released last year during the Sustainable Development Summit in United Nations last September. And this report has a theme, the title of "The Future is Now, Science for Achieving Sustainable Development." And in this report, it gives a model with 4 levers, which the first lever is here, governance. And the second lever for sustainable development is economy and finance. The third one is individual and collective action. The fourth one is science and technology. which our engineers are deeply involved in this field, science and technology. With these 4 levers, there are 6 so-called entry points for transformative action is proposed. The first entry point is human well-being and capability. The second one is sustainable and just economy. The third one is energy decarbonization with access. There's a renewable energy and so on and so forth. And the fourth one is food system and nutrition patterns. That's also very, very important. Last year, WFU has worked together with Tunisian Engineering Association to have a dedicated workshop on the food system. And the fifth one is urban and peri-urban development. And the last one is environmental and climate change in common. So the new model is to use these 4 levers integrated with these 6 entry points to promote the implementation of the SDG in a more comprehensive way. So to pursue a true transformative recovery, to realize the goal of build back better from the COVID-19. The emerging technologies, AI and big data, are proven to be a potential accelerator for the sustainable development. And to use these AI and big data and other emerging technologies to maximize its benefit for the good of the people, while minimize its potential negative impacts. The World Federation of Engineering Organizations, WFO, has proposed 7 principles for the responsible conduct of big data and artificial intelligence, innovation and application in engineering on the first World Engineering Day, that is the March 4th. Even though we don't have the big gather together in the UNESCO headquarters, we have announced these principles on the web, and you can find it from our website. Here, I just briefly show the 7 principles. First is good for the humanity and its environment. The second is fairness, inclusiveness, and public awareness. The third one is privacy and data integrity. The fourth one is open and sharing. And then transparency and accountability. Peace, safety, and security. Finally, collaboration. So let's stop here to call for a collaboration of the world engineers to fighting with current coronavirus crisis and working hard for a true transformative recovery, and by using the emerging technology in engineering to build back better. Thank you. Thank you for your attention.
The global impact of COVID-19 has had an impact on millions and has no geographic boundaries. In just 3 months, the virus has spread from Wuhan, China, to more than 140 countries. In comparison, in the 14th century, the bubonic plague spread the Black Death from China to Italy in the course of some 16 years, 1331 to 1347. This was a result of travel and trade between countries. For a similar reason, but much faster, the pathogen arrived within days but via a non-stop flight from Wuhan to Rome and other parts of the world. This is a consequence of globalization. And never before have we needed collaboration and governance for COVID-19. Because although we've had a significant global impact, there are differences in our capacities to combat this virus. It's clear that the world must come together to develop responses and for a vaccine for mutual global benefit. We cannot act alone within our own global boundaries. The UN Sustainable Development Goals have the objective of leaving no one behind. The world was moving slowly towards this goal, but progress in the last 6 months has been rapid as we collaborate against the threats of COVID-19. We simply cannot afford not to do so. Global collaboration against pandemics is nothing new. Since the late 18th century, the world sought new ways to collaborate and to govern globalization in order to promote its benefits while controlling its harms. The International Sanitary Conferences began in 1851 and continued until 1938 and were among the first modern efforts for global scientific and policy cooperation. This gave rise to the World Health Organization in 1948, one of the first major agencies of the United Nations, which was founded at the end of World War II. The WHO, of course, is currently at the center of the fight against COVID-19. WHO has helped to coordinate scientific information about the pathogen and how to control it, and to coordinate and monitor the global push to contain and end the pandemic. But disease control is not the only area where global cooperation is vital. The case for global cooperation and institutions extends to many urgent concerns. The control of human-induced climate change, which knows no boundaries. The conservation of biodiversity. The control and reversal of the massive pollution of the air, soils, and the oceans. And you see here a picture of the Sydney Opera House, where I live, covered in a smoke haze resulting from bushfires just earlier this year in January 2020, which arose as a result of climate change. The proper use and governance of the internet is another very important concern, and the need for education for all, especially in science and engineering. All these concerns are global, where we all need to act together to address for positive change. Francis Bacon once said, "Knowledge is power." And scientific knowledge is indeed powerful and provides us with the capacity to act. But modern scientific knowledge is not simply an understanding of the world, but an understanding that enables people to intervene and alter that world, thus manifesting an orientation towards technology and innovation. We engineers, of course, do this better than anyone else. And we have already heard of how engineers are making change for COVID-19 from the previous speaker, Professor Gomke. But we need to use this knowledge, this capability to develop collaborative solutions. We need to work in partnership, Goal 17 of the Sustainable Development Goals, and build strong institutions, Goal 16. We need to share our knowledge, and most importantly, to build capacity and support countries which have less capacity to solve our global problems together. So global collaboration also needs good governance in order for the benefits to be realized. And there are some key principles for global governance. So in the following slides, I will give some examples of what we mean by good governance and case studies from current work being undertaken in Australia and internationally. And I've also highlighted some important engineering advances in each. So the key elements for good governance in science and engineering are for partners to set and agree their priorities, agree who's going to pay the funding arrangements, agree on who will own the intellectual property, ownership of the knowledge that's created, ensure that the results of research and innovation are put into practice, into products that we can use, and most importantly, build capacity for the results of the research and innovation. Here is an example of setting priorities, which may be done by responding to demand from users, institutional priorities as they decide to collaborate, or thematic priorities. Here you see an example of a sewage treatment plant where the government priority on public health to track the spread of COVID-19 in cities has resulted in collaboration between the University of Queensland and the CSIRO, an Australian public research organization, to track the virus in raw sewage. This will enable geospatial mapping, an engineering innovation for tracking the virus in highly populated areas. And this technology is also being researched in other countries around the world. Another priority is, again, geospatial mapping in real time. And here you see a map developed by Esri to assist the government in Australia to track the spread of the virus, to assist in policy making about travel and lockdowns. And another priority is to assist our hospitals and medical workers in the rapid development of personal protective equipment like 3D printed face shields. In Australia, 3D printing has been used to design a face shield very quickly in Melbourne in collaboration by the Royal Melbourne Hospital, the Melbourne School of Design, and the Melbourne School of Engineering. You see here an image of the 3D printed parts, and that design was made public so that as many institutions in Australia and around the world could print these face shields quickly and cheaply. An international collaboration has also been developed with, for example, the Austin Hospital in the USA to produce a positive air pressure respirator or paper for, again, as protective equipment for medical staff. The important question is who is going to pay? Funding is very important in collaboration. Funding might come from government, from volunteers in kind, from major world bodies such as the World Bank. For example, the Coalition for Epidemic Preparedness and Innovations is a global group that aims to speed up the development of vaccines and cut short the pandemic. It is funding research, and artificial intelligence, as we have already heard, is being used for rapid identification of suitable vaccines. Governments around the world are funding research into vaccines, and some 100 vaccines are currently being tested. University funding, of course, can be targeted for specialized research. For example, nanosensors, a new kind of technology, is being used in New South Wales, in Sydney, to develop rapid detection of the virus without amplification. This technology uses sensors to detect the virus rapidly, like a lateral flow device, while giving direct evidence of it. I'm a board member in giving direction to this New South Wales Smart Sensor Network. And of course, once we develop the new ideas and the technology, who is going to own it? Intellectual property is always very tricky. And we need to understand who is going to share this knowledge, perhaps with licensing. Collaborative patent pools can be used to pool the knowledge and derive the revenues. or open access to information as a public good. We have a great example for HIV medicines and vaccines. In 2010, Unitate funded a patent pool for patent holders in the manufacture of generic drugs. This allowed many drugs to be developed at affordable prices, and these were sold all over the world and stopped the proliferation of HIV. A similar patent pool may be affordable drugs and vaccines against COVID-19. And of course, we want our research to be put into products and practice. This requires delivering results, communicating between researchers and users, developing manufacturing and production mechanisms, and of course, knowledge and training. For example, vaccines are being tested here in Geelong in Victoria in Australia, using molecules provided from the University of Oxford in the UK and Inovio Pharmaceuticals in the US. So it's an example of global collaboration to produce a product that will be used by people all around the world. And here another product that's already been put into practice, an emergency invasive ventilator that again has been developed in Sydney by the New South Wales Smart Sensor Network in collaboration with an electrical manufacturer, Circuitwise, and another company, Grey Innovation, using 3D printing and advanced manufacturing. So here, this product has quickly been brought to market to assist with ventilation, which has also been in short supply. And of course, Professor Gonki has already mentioned the capacity building work of WFEO with the knowledge hub that has been established on our website. And here we are providing information to build capacity to our 100 members, representing more than 30 million engineers. UNESCO as well is doing capacity building at no cost, using information and communication technologies to share knowledge across the world, and also to support remote learning for young people who have been so badly affected by their inability to attend school and university. And these approaches might help to develop more open and flexible education systems for the future. I share here some knowledge on emergency response in natural disasters because CIP hosts the committee, the WFEO Committee on Natural Disasters Risk Management. This poster was developed in Japan on how to shelter people affected by a flood in a COVID-19 environment, maintaining social distances. And this strategy was shared just last month at a meeting of Southeast Asia and Asia Pacific leaders organized by UNESCO. It's a great example of how engineers are collaborating, should share knowledge in these various platforms. So will we succeed? Will the world come together to collaborate in science and engineering for COVID? COVID-19 is unprecedented and has resulted in infections in most countries. So there is an imperative for us to work together collaboratively for detection, for response, and for prevention. Global institutions like the UN, the World Bank, the NGOs, and civil society are working together. And WFEO is also doing its bit in capacity building among its members. And what are the implications for the future? We have COVID-19 has accelerated collaboration between governments and universities and research institutions. Seemingly insurmountable barriers have fallen away in a few weeks. We have invented new technologies in many fields of engineering, and most importantly, we have found new ways to work together. The goodwill of engineers around the world working together in partnership will help to solve not only the problems of COVID-19, but I'm sure many other global problems. This is essential for engineers to facilitate the advancement of the UN Sustainable Development Goals, leaving no one behind. The lessons learned from global collaboration and governance will be important for the UN Sustainable Development Goals. especially in engineering and advanced technologies. Let's work together to leave no one behind. Thank you.
You have heard very good presentations from Dr. Gonke and Dr. Kanga, and I'm going to ask some basic questions in my presentation. And my presentation focuses on how does the society develop resilience to such unforeseen events. Because unless we look at the new ways to develop resilience, society will be devastated economically. So I go back to my basic question that we need to sustain the society for such an event, which is a black swan event, which I'll talk about in a minute. We must develop resilience in a different way. And that's the focus on my presentation. So before we focus on what will change beyond post-COVID-19, let's first look at the nature of the COVID-19. If you can go to the next slide. Okay, so let's look at the nature of COVID-19. Before we ask the basic question, post-COVID-19, what will change? What was the nature of COVID-19? Well, as I said, it was a black swan event, which means previously unknown virus medically. Black swan event only comes once in a blue moon, although they seem to be happening more often these days. There's no vaccine available for the cure. The transmission of the virus is due to the closeness of the individuals. It impacted globally, which has not happened before. And social distancing supposed to be the most effective as a prevention, because at the moment there is no vaccine available. So in a summary, the health and safety of the community became the predominant concern. Although it impacted the entire society in all aspects and destroyed many, many economies. If we go to the next slide. So let's look at what did COVID-19 change, first of all. Well, let's look at some of the realities here. Countries lacked resiliency to deal with such an event. Societies got impacted economically, socially, and technically, meaning in all aspects of infrastructure. If you look at the engineering systems, there were two things happened. One is a direct impact, which affected physical facilities, for example, places of assembly, manufacturing plants, public buildings, private office buildings, sports facilities, and many, many others. In terms of transportation systems, it affected all air, surface, and limited water systems even. The indirect impact of on engineering systems was power systems, electricity, gas, because people didn't know who's going to operate it. Are they going to be remote controls? People are going to work on it or not. Water and wastewater systems, collection and distribution got impacted because people could not come. Water got contaminated in many, many ways. And then there are special use facilities, which we depend on very critically. Nursing homes, elder care facilities, schools, higher education facilities, they all got impacted. These are very, very critical. Now the next slide. Okay, so what will change post-COVID-19? If you look at the resiliency, which we want to have in the society to deal with something like that, let's look at very quickly what resilience is all about. So resiliency is the ability to prepare and plan for, absorb, recover from, or more successfully adapt to actual or potential adverse events. Now, as my esteemed colleagues had said, that many, many things are going to change. I believe that, in my opinion, that only some things are going to change. And I would like to focus on those. So the response and recovery is based on context, meaning if you're in China, if you're in the US, if you're in Australia, you're in India, the context is different. So in the context-wise, the response and recovery on such an event is going to be based upon geographical, societal nature, economic status. The rich people can socially isolate, the poor people cannot. They have no choice. Cultural, there are religious aspects, there are political structure. So there are many, many issues that are context related. Then the available community capacity. In each community, the community capacity, and Marlene Kanga talked about the capacity building a little bit, but capacity is very different. We need tools and equipment, the available infrastructure for delivery of those, product innovation, which happens in many advanced countries but not in other countries, and the flexibility in manufacture. We found out very quickly that we needed a lot of ventilators available, and there were no ventilators available. There were no masks available in the US. So suddenly the companies were asked to produce masks, but they had no capability. So there has to be flexibility in manufacturing, quickly change that. So this is what is called the communal community capacity, which we're faced with, and it's a different in different countries. Impact for future, the engineering focus-wise, there are immediate impact and long-term impact. I'm not going to focus much on the immediate impact because those were primarily social disruption. So let's go to the next slide. Okay, so let's look at the resiliency components. So ability to prepare and plan for, it totally failed. We were not prepared and we could not plan for it. It's a black swan event. Absorb, only partially successful. Some countries did better than others. We are still struggling in the US. Recover from or more successfully adapt to actual events. Well, this is going to be a long and painful recovery. Adoption is very, very challenging. So immediate impact basically were just what I call a short-term disruptions. So these are temporary, so let's not focus on these. So let's go to the next slide. So here are some long-term impacts. So let's look at them rather carefully. So many services will be provided remotely because this method has proved to be more efficient. Suddenly we found that we can actually work from home, but successfully. So these things will change. Director supply chain will change from global to national, although we are global, but we found out that many political structure and many supply chain and countries don't want to really deal with others and so forth. Suddenly countries are dealing with, well, we need to have the supply chain locally available rather than globally available. So that's going to change. Work environment is going to change. Working from home is going to become more and more natural, probably more successful, also less traffic and all kinds of issues dealing with going to work. Medical services. We found out that at least in the United States, telemedicine is quite effective. So doctors' offices were closed, hospitals were closed. So people went by telemedicine to doctor for advice. That worked quite well. Less demand on physical space. If you're going to work from home, why do we need so much office space? Why do we need to go to retail centers or malls if you can order everything online from Amazon and Baba and so many others? So entertainment centers, cinemas and other venues, you don't need to have those because you can have all kinds of entertainment at home through electronic means. So this is going to change. The demand for physical space is going to change. There's going to be tremendous demand for online trade for basic necessities because you can almost order everything online. Even in less advanced countries, you can order lots of things online, although not all of them. Character of major cities are going to change because the fewer services are going to be needed. There's going to be less office space in major cities. People are going to be living in suburbs and not go to cities as much. However, if people are going to migrate more to suburbs or not going to the cities to work, then there's going to be more demand on the services in suburbs. There's going to be more and more demand. There's going to be tremendous demand on electronic tools, demand on social media, because that's how people communicated, kept with each other globally. There's more connectivity to remote areas will be needed. And I'm going to say in my last slide, but I want to mention something here more critically, that we all talk about connectivity and remote and basically Internet of Things and all kinds of things. 50% of the world today is still not connected by Internet. 50%. Let's keep that in mind when we talk about the progress and how we're going to be remotely connect. Investment is going to change forever. investment for buildings and infrastructure will undergo tremendous change because our investment climate has changed. If we don't have as many clients, if we don't need as many buildings, if we don't need as much infrastructure, or the nature of infrastructure is going to change, then the investment is going to change. So my point here is that only some changes will be permanent. As the vaccine gets developed, we'll probably go back to some of our old things and old ways of doing things. Let's go to the next slide. So let's look at what are some of the things which are likely to change. And this is, I'm viewing this through the lens of the UN Sustainable Development Goals. So engineering education, there are two aspects to this. One is the content and one is the delivery. The content part is going to change significantly. There is going to be less emphasis on traditional individual disciplines. There's going to be more focus on bioengineering and connection to medical disciplines, as Gonki and Marlene Kanga had said already. But there's going to be a lot more stronger connection with these fields. There's going to be more focus on robotics, artificial intelligence, machine learning. There's going to be changes in information technology discipline. There is a lot of information technology available, but how do we utilize it in different ways, like telemedicine? How do we utilize in construction sites and so forth? Transdisciplinary approach, societal problem focus. This is something which is going to be more and more focused in the content of engineering education. We need to have a societal problem and we need to all work together on it as a multidisciplinary, transdisciplinary approach. There's going to be inclusion of pure and social sciences in the curriculum. At least we see happening in the US in some ways, but as the university structures are very rigid, this is going to take a long time for it to happen, but it needs to happen. Preparing students culturally to work in global environment. Well, we talked before that we are going to be more and more nationally oriented, but people are still going to work in a global environment. And we need to prepare them culturally, which is going to change. From delivery standpoint of engineering education, there is going to be more focus on distance learning rather than the physical space in universities and schools. There's going to be remote teaching, so less classroom attendance. And there's going to be a global student body. So more online courses. I mean, there are online courses right now, but there's going to be more and more of that, and globally, students will be participating more. Next slide, please. There are two other issues which I like to talk about: construction. There is going to be less direct physical contact. How do we do that? We don't know. More remote control tools and equipment. I mean, I was in Japan 3-4 years ago, and I saw how remotely you can control several hundred feet, or at least a couple of miles, it seemed to me, constructing a dam by remote control equipment. So there's going to happen more and more. There are going to be new sensors for inspection and quality control, larger use of prefabricated products from control environment so that you don't have to work as much on the construction side. And there are going to be use of new composite materials, which are going to be long lasting and basically what I would call germ-free in a way. But a lot of new developments are happening in composite materials. Professional practice-wise, there's going to be a convergence approach to problem resolution. When I say convergence, I mean this is transdisciplinary or different disciplines and sciences, including social sciences. They need to come together to solve a problem. Now, we have never dealt with this in a professional practice as engineers, but we need to approach it on that basis to have problem resolution. Our advice to clients, particularly public agencies, is going to be quite different because they will have to deal with this kind of unusual events in a different way. So we need to really carefully think about, it's not just going to be engineering advice, it's going to be a lot more comprehensive advice on how to deal with a problem. Remote work environment we talked about already. Electronic transmission of documents between agents. We do that even now to some degree. There's going to be a lot more electronic transmission of drawings and specifications and things like that, even to the job site. Changes to specifications in many, many ways. The way we write specifications today are going to be changed significantly because the ways of constructing, the ways of operating are going to be quite different. And then there's a development of new technologies and better connection to academia and research institutions. Both Gonki and Marlene have covered this, but this connection is going to get stronger and stronger. So we come back to how to develop resilience in societies for such events, which nobody had faced before, and we don't know how to deal with it. So let's go back to the couple of last slides here. Next slide, please. If I look at UN Sustainable Development Goal number 11, which is kind of over encompassing for all the different goals, what it tells you is sustainable cities and communities. It says make cities and human settlements inclusive, safe, resilient, and sustainable by resource utilization, considering long-term costs and creating a circular economy. So that's an overall goal. But the underlying scenario here is that if we're going to have communities sustainable and resilient, which is a part of being sustainable, such events, we need to look at sustainability in a totally different way. So let's go to, rather than looking at the prerequisites, which is kind of in a detail here, which I don't really want to go into the details here, except to kind of say two things here. One is a future city is going to be shared vision by all. And there has to be a trust between different stakeholders. The trust is an issue in a situation like this, in a coronavirus. Trust is lacking because we don't want to go to near each other. We want to have social distancing. Who do we trust? Who's carrying the disease? We don't know. So we need to be sensitive to different cultures. We need to practice socioeconomic realities, what they are in a particular context. And then economically, we need to have financial and non-financial resources to deal with such an event. We need to have resilient and sustainable practices and promotion of public-private partnerships, which Marlene Kanga talked about quite a bit in various sectors. So if we go back again to the final slide, impact for the future. Next slide, please. Post-COVID, what will change? If you look at make cities and human settlements inclusive, safe, resilient, and sustainable, our fundamental approach to develop resilience or black swan event-like events is going to change. That has to change. So what does that mean? So we already covered some of those things. It means remote control systems, tools and equipment. It means remote and global engineering education. It means more use of artificial intelligence, robotics, and machine learning. It means big data analysis, transdisciplinary methods, convergence approach to solve large societal problems. So a word of caution, as I said before, that only 50% of global population can access internet resources. So when we develop solutions to resilience, let's keep this in mind. Resilience is global. If we cannot do everything remotely, we need to have we need to have dual approach. Somewhere people where we can remotely access, we need to do that. Where we cannot remotely access, we need other solutions or still develop resilience to something like a black swan event. I'm not quite confident as to how much will change, but some things will change. And some of the areas that are likely to change, which I presented here, but I'm not, in my mind, quite sure what is going to change permanently. But I hope I presented some scenarios here that some things are going to change, and we are all in this together. And thank you very much again for listening. I'm sorry we had a problem with the presentation. I really apologize that, and thank you for inviting me again. Thank you very much.
Sí, buenas noches. Primero que nada quería agradecer la presentación de nuestros tres expositores previos por las extraordinarias presentaciones que he hecho. Acabo de cambiar de inglés a español. Preferí escucharlas directamente en inglés y sentir el sabor de escucharlas directamente, recordándome las veces que hemos podido estar juntos en tantas oportunidades antes. Y creo que entre los tres conjuntamente han hecho una extraordinaria presentación que cubre todos los aspectos o la gran mayoría de aspectos trascendentales en lo que representa la COVID-19 para la humanidad. Nosotros como Colegio de Ingenieros, cuando nos vimos frente al problema, la primera actitud nuestra fue tratar de dimensionar el problema. Entonces, una primera pregunta elemental era, ¿de qué se trata todo esto? Y al final vimos que era una lucha en la naturaleza entre un ente, formalmente para los biólogos, sin vida, y una especie animal inteligente, la única inteligente que hay en el planeta, que somos nosotros. Donde además, curiosamente, no era el interés del virus, de este ente, destruirnos, porque si nos destruye, se destruye también él. Entonces, si hubiera podido pensar o hubiera podido tener conciencia, lo que habría buscado es una convivencia con la especie humana. Y esa convivencia con la especie humana significaba difundirse totalmente en ellos. Y que en ese proceso iban a morir los individuos débiles, los que no podían soportarla, e iban a quedar los que podían convivir con ellos, ¿no? El segundo tema es, la segunda pregunta es, ¿cuánto va a durar esto? Al comienzo, la mayor parte de la gente en nuestro país, y creo que en muchos países del mundo, recibió el aviso que teníamos una cuarentena de 2 semanas. Entonces, gran cantidad de la gente estaba convencida que en 2 semanas el mundo comenzaba de nuevo. Yo me acuerdo, tenía un trabajo profesional y en los primeros días me llamaron para que lo presente en una presentación pública a fines del mes de marzo. Y mi comentario fue que yo dudaba que al fines del mes de marzo alguien pudiera interesarse en lo que teníamos que decir o en otra cosa que no sea la COVID-19, y el tiempo nos dio la razón. Entonces nos preguntamos, ¿qué tiene que pasar para que se vuelva a una normalidad? Entonces, que el ser humano haya encontrado las armas. Entonces, la primera arma era la vacuna, pero no solamente encontrar la vacuna, sino que esa vacuna puede llegar a la mayor parte de la humanidad. Y la segunda es que la capacidad del sector salud, la capacidad de los hospitales, pudiera volver a ser la suficiente para atender normalmente, no solamente a la COVID-19, sino a todas las enfermedades que en muchos lugares del mundo han sido descuidadas para poder atender a la COVID-19. Y eso me llevó a pensar que estábamos ante un problema de difícilmente menos de 2 años, quizás de más de 2 años. El tercer tema era, ¿cuál era la dimensión del impacto? Entonces, preferí entenderlo a través de una analogía. Nosotros en el año 2017 tuvimos un año muy especial con el fenómeno del niño, la niña o el niño costero, una variante que se denominó así de lo que ocurre antes 50 años. Y de hecho, cuando ocurren precipitaciones de agua torrenciales que superan largamente las condiciones corrientes, la capacidad instalada no alcanza. Y eso es en cualquier actividad, porque una actividad puede tener un sobredimensionamiento de 10 o de 20% que puede ser asumido fácilmente por los costos corrientes, pero no puede tener una sobrecapacidad de 200%, es decir, 200% encima de lo que necesita. Y cuando se iba a presentar una circunstancia así, sea que un sistema esté muy bien preparado, excelentemente preparado, o sea, como el caso peruano, que creo yo que estaba apenas preparado, casi en el balance y a veces un poco por debajo del balance, obviamente nos iba a sobrepasar. Entonces, si nos sobrepasaba, los daños iban a ser terribles. En nuestro país, el enfoque político, que fue bueno, creo, fue primero está la salud y después la economía. Y creo que fue un excelente enfoque. Claro, pero eso solamente para el primer tiempo, porque después de un cierto tiempo, la economía iba a apretar tanto que finalmente iba a quedar la economía encima de la salud, en una lucha de largo plazo, que es finalmente lo que ha sucedido en una parte o en otra parte del mundo. Entonces, la primera actitud de nosotros fue dimensionar el problema, tener una idea de la magnitud, de los alcances, para ver también qué cosas hacíamos con los recursos. El siguiente tema es cuál iba a ser nuestra actitud ante esta situación. El Colegio de Ingenieros tiene algunos recursos, algunos pequeños recursos para ayuda a sus asociados. Entonces, el tema básico fue, aquí no hay democracia, aquí lo que hay es solidaridad. Es decir, no es igual para todos, sino concentrar en los que necesitan y que los que se pueden defender solos se defiendan solos, entonces para que los recursos puedan cubrir a una mayor cantidad de personas. Y la pregunta siguiente era, ¿cuál es el mundo después de la COVID-19? Sentíamos que iban a haber varios cambios que iban a ser permanentes. Entonces, en nosotros, en la adaptación que tuvimos que hacer ya como colegio de ingenieros dentro de nuestros propios protocolos, nuestras propias formas de actuar, preferimos hacerlos ya como cambios permanentes. Los hemos incorporado incluso a nuestros estatutos para cubrir detalles hasta tales como la validez legal de las actuaciones que podamos tener, las formas en que se aprueban, etcétera. Descubrimos varias cosas interesantes. Como ingenieros había muchas cosas que no ignorábamos y sabía que eran posibles. Pero otra cosa es vivirlas y otra cosa es practicarlas. Entonces, las reuniones como estas se hicieron reuniones corrientes. Nosotros teníamos generalmente 2 reuniones por año donde participaban directivos de las distintas regiones que tiene el país. Nosotros estamos en 28 sedes a lo largo del país, entonces eran reuniones con 100 personas, reuniones difíciles porque habría que hacer coincidir los horarios de 100 personas porque tenían que viajar. En algunos casos los viajes tomaban 2 días para llegar al sitio donde se iba, otros 2 días para regresar. Aquí descubrimos que con toda facilidad lo podíamos hacer a través de este medio y llegamos a tener una sesión justamente para modificar los estatutos en la que participaron 100 personas y donde pudimos analizar punto por punto los temas para al final llegar a un acuerdo que es nuestro acuerdo de base como institución de ingenieros sobre la cual íbamos a operar y que son los principios que hemos tratado en todo este tiempo. La lucha, esto ha sido una lucha, es una lucha y va a ser siendo una lucha. La lucha también ha servido para mostrar las debilidades que tenemos y la vulnerabilidad que tenemos y la necesidad de cambios para poder justamente confrontar y evitar tener esas debilidades. Tampoco podíamos dejar de pensar que en el origen, de alguna forma, hay un vínculo entre lo que está sucediendo y el tamaño de la huella que el ser humano está dejando en la naturaleza. O sea, la presencia del ser humano en la naturaleza ha sido muy grande y entendemos que la vida es un balance entre varias especies. Y en ese balance la población humana ha crecido enormemente y otras poblaciones se han ido deteniendo. Ese es un tema que tenemos que mirarlo con bastante cuidado. Ya la UFEO y nosotros como Colegio de Ingenieros nos adherimos inmediatamente, justo después, a las pocas semanas después de la reunión de Melbourne, cuando se declaró ya la emergencia climática, ¿no? Un cariz de emergencia, las acciones que había que tomar contra el cambio climático. Y ya anteriormente, en la gestión de Marlene, se habían tomado las medidas para que la actitud de los ingenieros en el mundo en general se plegase a las metas de conservación del planeta, lo cual también nosotros como institución respaldábamos totalmente. Entonces, no es menos cierto que es una lucha que va a tener costo, que tiene un costo social, que tiene un costo económico y que ese costo estamos obligados a pagarlos de todas maneras. Pero también entendemos que es una lucha que va a traer muchos conocimientos, muchos cambios, muchas oportunidades, muchos beneficios. Y nuestro trabajo, nuestra tarea, nuestra actitud como ingenieros es que el mundo que emerja de este cambio, que no va a ser el mundo que conocimos antes de él, sea un mundo mucho mejor. Y por eso escuchar a los tres distinguidos conferencistas que me precedieron en el uso de la palabra ha sido para ese propósito muy importante, muy relevante. Nosotros, al interior del país, desde un inicio pensamos que se nos iba a necesitar. Entendíamos, algo donde en primera fila iban a aparecer los médicos y la lucha de los médicos, pero en realidad éramos los ingenieros los que les dábamos las armas a los médicos. Entonces, las armas con las que esto se luchaba eran armas dadas por los ingenieros. Y es el tipo de luchas, en las luchas antiguas, en los tiempos antiguos, el valor de los guerreros era determinante en el éxito de las batallas. Si me remonto a la Ilíada, pues la dimensión de un guerrero como Aquiles era importantísimo en el éxito de una misión. Hoy en día son las armas. Y ya los guerreros casi no importan. Y si en esta lucha, hoy en día, en el frente de batalla, en nuestro caso por lo menos, hemos tenido médicos en unos casos, policías en el otro caso, tratando de mantener la cuarentena y el aislamiento los segundos y los primeros luchando con la enfermedad, con varias víctimas, con varios muertos en todo este proceso. Si bien eso es cierto, y detrás de ellos hemos estado los ingenieros apoyándolos, soportándolos, por supuesto que la organización es fundamental, por supuesto que el apoyo económico, la capacidad económica es fundamental. La buena posición económica del Perú le ha permitido una lucha muy difícil porque las características de nuestro país hacen que sea más difícil que en la mayoría de países poder contener un frente como estos. Pero también la pregunta es, casi hay una regla de una pandemia cada 100 años. ¿No? La última fue en el 1920, le llamaron la gripe española porque había aparecido en varios países y en el primero que aceptó que era una pandemia fue España, entonces se la atribuyeron a España y se llamó la gripe española. Quizás la siguiente ya no va a esperar 100 años. Quizás la siguiente va a esperar, ¿cuánto? Un cuarto de siglo, 20 años, un tercio de siglo, 30, 33 años, medio siglo, 50 años. Pero el avance tecnológico, el desarrollo humano, quizás permita que esa vez quienes estén en el frente de lucha ya no tengan que ser médicos. De repente van a ser robots. Todo eso es lo que viene para adelante. Y finalmente recogíamos esta ley en la naturaleza en todas las supervivencias que han tenido las especies y cuando se han producido las extinciones. quien sobrevive no es el más fuerte. Quien sobrevive es el que se puede adaptar a los cambios que necesita para poder vivir. Entonces, de nuestro lado, el mensaje final es que los ingenieros estamos para dar, no para pedir, que los ingenieros somos fundamentales en una lucha de esta naturaleza, porque en esta lucha el arma es la tecnología, la innovación en la tecnología, la adaptación de la tecnología, la rapidez y la capacidad de poder sacar nuevos métodos, nuevas armas, nuevas formas, es sustancial en los resultados. Por supuesto que hay otras cosas que contribuyen fuertemente. La disciplina en las naciones, la rapidez de una nación en alinearse a los pedidos de su gobierno. En el nuestro no ha podido ser así por distintos motivos, también son fundamentales. Pero siempre, después de que la luz se apaga, vuelve a aparecer, después de que el sol se pone, vuelve a amanecer. Entonces estamos seguros que habrá un mundo nuevo, mejor, que se reconstruirá de repente más rápidamente de lo que pensamos, que los ingenieros vamos a participar profundamente en ello, que la colaboración es fundamental y que es un siglo que por el avance de la tecnología hace que la participación de una profesión como ingeniería deba ser una profesión líder en el mundo, que sean para bien de la humanidad. Entonces, preparémonos a continuar la lucha, pero estamos seguros que finalmente vamos a vencer y que vamos a poder construir un mundo mejor. Muchísimas gracias.
Muchas gracias al ingeniero Herrera por su importante intervención. Antes de proceder a las preguntas y las respuestas, es importante notar que hemos tenido por la vía del Zoom cerca de 730 participantes y por la vía del Facebook más de 950. Entonces esto ha suscitado bastante interés. Y también antes de pasar a las preguntas y las respuestas, a título personal, quería nada más hacer una observación que todos los expositores nos han indicado que estamos frente a desafíos globales. Tanto el cambio climático como el COVID-19 son amenazas para toda la humanidad. Y entonces requieren soluciones colectivas de toda la humanidad. Y el rol de los ingenieros, cuyas decisiones se sustentan en la ciencia y en la ética, pueden trascender las consideraciones políticas o ideológicas que a veces impiden la colaboración. Y creo que más que nunca esta es una profesión que debe de ser puesta en el máximo valor porque va a permitir una convergencia de criterios para hallar soluciones colectivas para problemas colectivos. Entonces, ahora vamos a pasar a oír algunas de las preguntas que están dirigidas a los distintos expositores. Voy a ir nombrándolas y según a cuál expositor van dirigidas. Entonces, acá para el profesor Gonke, quiero empezar con: ¿se adaptaron las empresas a una nueva normalidad con las especificaciones de bioseguridad o hay que seguir las pautas del gobierno? Esa es una primera pregunta. Tal vez le voy a dar una segunda pregunta. Vienen más, pero tal vez dosificándolas para que pueda responder adecuadamente. ¿Cuál es la diferencia respecto a la mitigación para combatir el COVID-19 en la construcción civil en China y en Perú? Bueno, eso creo que sería una respuesta que tendría que... Sí. ¿Cuál es la diferencia respecto a la mitigación para combatir el COVID-19 en la construcción civil en China y en el Perú? Creo que esa tendría que ser una pregunta respondida por dos expositores, pero que previamente también tendrían que contrastar cuáles han sido las políticas en cada país. O tal vez sea bueno que responda a grandes rasgos cuáles son los criterios de mitigación en la construcción en China. Lo pueda responder el doctor Gonque, y el ingeniero Herrera pueda responder acerca de la mitigación para combatir el COVID-19 en la construcción en el Perú. Esas serían las dos preguntas iniciales para dejarle al profesor Gong.
Hello, thank you. Thank you for the question. My idea about the mitigation measures in China and in Peru, it might be partly in common and partly different. As just pointed out by Dr. Majuda, these measures are context related. We have different geospatial environment of China and Peru, and we have different political and economical structure of these two countries. That is different. So the effective measure for mitigation natural disaster like the public health disasters crisis should be adapt to its own geographical, environmental, political, and economical, even technical context. But on the other side, this crisis is a problem from the species, a new species, and they try to come to the world, and as said by Carlos, to coexist with human. And we have to adapt this and to mitigate the negative impact of this new virus. So that is the question of science. That is in common. We have to understand the nature of this virus and to find a scientific approach to treat with this virus. That is the same. For example, for the vaccine development, we need international collaboration. And we also share the experience. For example, this time in China, because Wuhan and Beijing is a city so crowded. Wuhan is a city with, I think, 15 million residents. So we in China, we have pursue a very strict measure for isolation, for the confinement. But perhaps that is not the case in Peru. So my idea is to adapt to the disaster and the crisis in the context of his own nation, but makes the measures in common with the scientific tools. That's my answer. Thank you.
Ingeniero Herrera, ¿quiere añadir algo al respecto? Perdón. Sí.
Hola. Yo coincido totalmente por lo dicho por el profesor Gonqué. Mi raciocinio es que en todo el globo están frente a frente el virus y el humano. El virus es el mismo virus y el humano es el mismo humano en todo el mundo. Entonces, lo óptimo en favor del humano para la relación y las precauciones entre ellos debería ser igual. Allí no están las diferencias. Las diferencias están en la capacidad de practicarlo y en el deseo de practicarlo. Entonces, la capacidad está en función de los recursos que tengan los países, las necesidades que tengan los países, y la voluntad de aceptarlo, de practicarlo, está en función de las personas, de la actitud de las personas. Si me guío por lo que hemos visto en el Perú, son casos puntuales de actitudes que se ven, pero hemos visto personas, por ejemplo, que tienen un abierto desafío al virus, ¿no? Y otras que, como no pueden circular por las calles sin máscaras, se llevan las máscaras, pero no bien puestas. O sea, para la forma en que tienen puesta la mascarilla, da lo mismo que no la tengan, ¿no? Entonces, es efectivamente, como dijo Vilas, es el contexto lo que los va a hacer diferentes, ¿no? Y esto en general, no solamente en Perú y en China, sino creo que entre cualquiera que sean las localizaciones en el mundo. Las medidas que dicten los gobiernos no necesariamente van a ser iguales los métodos, pero también permanentemente los gobiernos, cuando toman estas medidas, están confrontando sus resultados y están examinando también las medidas de otros países. Entonces, hasta allí hay una cierta similitud. Pero, o sea, la semejanza está en que, llamémoslo así, biológicamente es lo mismo en cualquier parte del planeta. Y lo que es diferente en cualquier parte del planeta es el contexto.
Bueno, muchas gracias, ingeniero Herrera. Creo que, como leí hace poco, estamos todos en una misma tormenta, pero no en el mismo barco. Y creo que es importante que ninguno de los barcos naufrague. Quiero seguir con más preguntas para el profesor Gonqué. Estas son perspectivas para la agroindustria en este escenario. Y entonces, aquí se habla en un contexto más futurista, de 5 años. ¿Cuáles son las nuevas tendencias que están surgiendo actualmente y están cambiando la perspectiva del mundo que ya se tenía? ¿Y qué áreas están sufriendo un cambio más repentino desde el punto de vista de tecnología en todo el campo de la ingeniería a nivel mundial? Lo dejo, no es la última de las preguntas, pero creo que estas le dejo para que responda a estas primeramente. Si desea, lo puedo repetir.
Thank you.
Sí.
No. I understand the question. That's a very good and big question. I try to answer this question partly. For the future trends, in the recent years, we have already seen a big revolutionary trends. That is the digital technology. Digital technology is widely used in different areas and make big changes. For example, in this crisis, without digital technology, even though half of the population could not access into the internet, but internet has made our life different in the past years, especially during this crisis. And we also see another new trends, which is built up on the internet. That's the big data. The internet produces every second a big amount of data. And these data bear a lot of information that will help the human to understand the globe, to understand the environment, to understand the society. And these big data has been treated with a high computational power. Now we have the power with a big effective tool that is artificial intelligence. So the combination of new generation of internet, I mean the internet linking not only human to human, but also linking equipments, linking machines, linking vehicles. We call it Internet of Things. That's a new generation of internet. And this new generation internet combined with big data, combined with artificial intelligence, combined with the high performance of computer, and also combined with the new material, renewable, the composite material, combined with new energy, renewable energy, that will bring a big change of our world. That we are expected is a transformative change to the sustainable development, to reduce the carbon emission, to reduce the unnecessary waste of the valuable energy, and so on and so forth. So pay attention to the digital revolution and to adapt into this revolution is a obligation of today's engineers. That's my answer.
Muchas gracias, profesor Gong. La siguiente pregunta es, ¿la ingeniería en tiempos de COVID-19 viene de la mano de la ciencia? ¿En qué manera afectará negativamente entre todas las diversas profesiones a largo plazo? Creo entender que la pregunta es cuáles son los impactos negativos que puede haber sobre las diversas profesiones a largo plazo por el hecho de que la ingeniería viene de la mano de la ciencia.
I don't think I can answer this question properly. But we see the COVID-19 does demonstrate a big challenge to today's science and today's engineering capacity to be resilient to this so-called black swan event, as mentioned by Dr. Majuda. So far, we have not developed effective vaccine to protect human life from this new virus. And that tells us today's science and today's technology and engineering capacity we have is not good enough to meet the challenge of natural disaster, public health crisis, and in general, sustainable development. And I could not say specifically the COVID-19 gives some negative impact to certain engineering subject. But I think COVID-19 wake us up to work together, to break through the barriers between nations, the barriers between industrial sectors, the barriers between academic disciplines, So that is really the barriers which prevent us to be more stronger to treat with these problems. So I actually don't see any area specifically negative impacted by the COVID-19, but I do perceive the warning from the COVID-19 for the multidisciplinary collaboration, for the multilateralism, the international collaboration, and the closer science policy interface. So the government should listen more from the scientific, technological, engineering society. So that's my perception from the COVID-19.
May I add a comment, Mr. Stoddard? May I add a comment? Thank you. I wanted to add to this question of the relationship between science and engineering. It's a very important question, and it's a question that's often asked. I wanted to clarify that science gives us a better understanding of nature and our world. And it is like the seed which plants a tree. And engineering is the tree that bears the fruit of this science. So we take this understanding of the world, the scientific discoveries, and we translate these into practical solutions that the world can use. So science and engineering go hand in hand, and never more so than at COVID-19, where the scientists are working on the understanding of the vaccine, for example. But the manufacture of that vaccine and the distribution of that vaccine will be done by engineers. So we engineers have a very important role. And as to the future and how it will evolve, I think the use of digital technologies in engineering will become very important. It'll become more important for engineers to be able to use artificial intelligence, machine learning, and information and communication technologies within their own disciplines. For example, in agricultural engineering, you would need to use sensor technologies and data, for example, measuring and monitoring moisture levels in the soil, to use automated robotic systems for watering your crops. This is technology that is being used in Australia, and even farmers are becoming experts in robotics and artificial intelligence. So this is something that all engineers will need to embrace, and the boundaries between disciplines will slowly disappear and be replaced by these new technologies that we will have to take up. Thank you.
Gracias. Aprovechamos entonces también una pregunta dirigida a la doctora Kanga. El Perú y el mundo entero afrontan una grave crisis por la pandemia COVID-19. En la industria alimentaria, ¿cómo podemos afrontar esta crisis para que los productos sean procesados de manera adecuada y que las personas no tengan temor a consumirlas?
Yes, thank you. Yes, thank you for that question. I am a chemical engineer, but no expert in food processing. But I think what COVID-19 has shown us that more and more food will be processed locally. We will have less reliance on imported foods and more on national products, which I think is a good thing for climate change and for more sustainable development of food. I think also new technologies will evolve, including using more automation and robotics to process and package foods to ensure that it is safe, because to reduce contamination risks. So these are the kinds of issues that again involve engineers. Engineers will be involved in designing and developing these new systems, new logistical frameworks as well, and transportation for food. But I think generally we will see in the future more trends to national food systems and production systems rather than the trend to globalization. Thank you.
Muchas gracias. Ahora una pregunta para el doctor Vilas Mujumdar. Dada la coyuntura mundial, ¿cuál debería ser el perfil de los nuevos ingenieros en el mundo?
So this is it's a very important question. As I said in my presentation, the traditional disciplines of engineering are slowly going away, and for good. But that doesn't mean that we are emphasizing less on the traditional disciplines. What it means is that we need to incorporate other disciplines in the overall engineer. So what does that mean? So let's just go back for a second to the food question which you said, which is not really related. But there is a worldwide movement now to go away from the meatless food to the meatless food, because there's a less contamination problem from the animal protein to the human. But be that as it may, what it means for engineers. So we need to understand in a comprehensive way, if we're going to solve a problem which we don't know anything about, which comes suddenly to us, which we never faced before, we need to work together with not only different forms of engineers, different types of engineers, but we need to work not only with scientists, but also with social scientists. And why social scientists? Because many, of course, everything has been used by the humans. So we need to be very cognizant of the cultural aspects, the socio-economic aspects, the religious aspects, what people adopt, what they don't adopt, how people are educated, not educated. So we as engineers, when we are put at the table to resolve a problem along with everybody, we need to understand where other people are coming from. So my classic example is when we say risk, a risk to an engineer means something different to a social scientist, means something different to an economist, something different to a pure scientist. But if we are together, when we say risk due to COVID-19, as long as we understand what everybody is talking about, that's where the new engineering is going to be all about. It's going to be very comprehensive, it's going to be very transformative, and it's going to have a convergence approach. That's what the new engineer is going to be, had to be, in my opinion.
Gracias, doctor Mujumdar. Vamos ahora a plantearles algunas de las preguntas para el ingeniero Carlos Herrera. Entonces, y después habrá una última ronda de preguntas. Recordamos que hay mucho interés, pero el tiempo es implacable acá. Entonces, una pregunta para el ingeniero Herrera es, ¿cuál es el papel que juega la ingeniería en estos tiempos de pandemia? Y otra pregunta es, ¿cuál es el impacto para los ingenieros en el futuro laboral en el Perú? Lo dejo con esas dos preguntas.
Gracias. La primera pregunta, un poco toqué la respuesta cuando tuve la oportunidad de la palabra, cuando decía que la ingeniería, no es la ingeniería en esta lucha contra la pandemia está en todo lo que es la logística y el soporte, y eso es fundamental para poder tener éxito. le puedo decir, más fácil es, creo, poner un acto que dar un tema general. El Perú en estos momentos tuvo escasez de oxígeno, tuvo problemas de oxígeno y los precios del oxígeno se multiplicaron hasta unos niveles inimaginables. El Colegio de Ingenieros reunió un grupo de personas. El sábado pasado, es la primera vez que salí en 90 días casi de estar en casa encerrado, y tuvimos una reunión con el primer ministro y le ofrecimos una solución. Le ofrecimos ayudar al sector salud a resolver de la forma más rápida, más efectiva, más segura el tema de oxígeno. Entonces, ahí es cuando, a raíz de una conversación entre varios ingenieros, analizando lo que es un hospital, llegamos a la conclusión que un hospital es un complejo tecnológico de alto nivel de tecnología. Y entonces que la profesión más apropiada para eso es, para el manejo de eso, en lo que es el diseño, la construcción, la operación del conejo, es la de ingeniería. Y así en distintos aspectos. En lo que respecta al futuro, también de alguna manera toqué la respuesta, porque yo lo que veo es la necesidad de muchos cambios, todos ellos en base a tecnología, para moverse al nuevo mundo, a la nueva situación a la que vamos a ir. El doctor Muyundar hizo un excelente análisis de varios detalles de las cosas que van a cambiar. Así, un pequeño detalle es todos los que podemos trabajar vía teletrabajo. Hemos hecho algún espacio en nuestra casa para que sea un nuevo puesto de trabajo. Y eso ya significa cambios en las viviendas a futuro, en la distancia, ya no tiene uno que estar metido en el centro de la ciudad, etcétera, etcétera. Entonces, le deja a los ingenieros la oportunidad de ofrecer servicios en base a su creatividad. Cuando uno habla de ciencia y tecnología, ciencia es lo que siempre existió en la naturaleza. El ser humano, frente a la ciencia, lo que hace es descubre las leyes de la ciencia, pero él no influencia las leyes de la naturaleza. Las leyes de la naturaleza están dadas. Y lo que sucede es que cuando las conoce, las utiliza para crear productos, servicios que nunca antes existieron. Y esa es la función de ingeniería. Y en esa función de ingeniería hay mucho de ciencia, que es el conocimiento del cual se parte, y hay algo de arte, que es la creación, la inspiración, es lo que agrega a la persona que produce ese servicio. Entonces, es cuestión de mirar el mercado y se encuentran muchísimos servicios. O sea, para los ingenieros, después de esta crisis difícil, todo, se abren enormes oportunidades. Sería mi visión del tema, ¿no? Y por eso es, como dije en algún momento, el costo social lo estamos pagando, tratamos de que sea el más bajo posible, pero no hay forma que nos escapemos de viajar, de pagar el costo social, porque no está a nuestro alcance. Sin embargo, la consecuencia de eso es un mundo de oportunidades.
Muy bien, gracias, ingeniero Herrera. Una última pregunta para usted y después una última ronda de preguntas para los demás expositores. En el Perú ya varias empresas están empezando sus labores en tiempos de COVID-19. ¿Qué medidas serán más necesarias para que las empresas e industria peruana crezcan en todos sus rubros?
Las medidas de tipo COVID-19, creo que todos más o menos conocemos a través de esta oportunidad de haber estado tanto tiempo pensando en el tema, conocemos el problema con la COVID-19. Entonces, es más una cuestión de actitud. Todo el mundo sabe que tiene que tener una distancia hacia otra persona, sabe que la máscara es para que uno no contagie a otro, más que para no ser contagiado, y sabe las precauciones que hay que tomar. Entonces, desde ese punto de vista no hay demasiado más que hacer que no sea la propia actitud de las personas. Lo que venga después dependerá mucho de la forma por la cual vayan las cosas. Yo lo que hacía como distinción es, decía, en nuestro país, por ejemplo, en muchas actividades que se realizan en gran escala, otras que se realizan en pequeña escala. Para las que son en gran escala, se pueden tomar todas esas medidas, todas esas precauciones, y aún así son difíciles de ejecutar. Más que nada por la actitud de los trabajadores. En lo que es la pequeña escala, yo sí no veo cómo lo van a hacer, si soy franco sobre el tema, porque el costo de las medidas para la pequeña escala es tan grande que la actividad se volvería no rentable. Entonces, va a ser casi una decisión individual de qué cosa es lo que hace y hasta qué punto las implementa. Y por eso el temor que también cuando hicimos nuestro primer pronunciamiento como colegio dijimos es que el momento difícil iba a ser después que se levante la bandera y se comience a progresivamente ir levantando la cuarentena. Entonces, esto ha pasado recién hace 10 días y seguramente los resultados los vamos a saber en una semana o algo más.
Bien, muchas gracias, ingeniero. Una pregunta para el profesor Gong. ¿Qué recomendaría a los ingenieros y arquitectos jóvenes que recién egresan con respecto al área en el cual deberían enfocarse para sus respectivas especializaciones, considerando la situación actual de emergencia que afrontamos por motivos del COVID-19 y que el país se tendrá que recuperar económicamente?
Thank you. That's a very good and important question. Partly, I would like to give an answer from my personal view. For a young graduate, it is very important to understand the sustainable development, the nature of the sustainable development is deeply rooted in science, and that is deeply rooted in history. So as a young graduate, no matter from which discipline, should have a better understand of the sustainable development and the set goals for the 2030 by the United Nations, and to combine these sustainable development goals with his or her own profession, his or her own job, and try to make real actions in his or her job to implement the sustainable development goals. So that's my suggestion. Thank you.
Muchas gracias, profesor Gang. Ahora una pregunta para la doctora Kanga, que es ¿cómo lograr una cooperación eficiente global de tal modo que garantice una inmunización efectiva y accesible para todas las personas de diferentes sectores económicos?
Yes, thank you. Yes, a very important question. Thank you very much. I think firstly, global cooperation is absolutely essential for us to find solutions for everyone for these very large problems that are global problems and don't have any geographic boundaries. I think we need to work with our national institutions like CIP, and through the national institutions, through global organizations. The World Federation is doing its role for engineering, but there are other global organizations in science, in medicine, and of course the United Nations. These are the institutions that will drive global collaboration. Global collaboration is also being driven by partnerships between universities across different countries and across companies. But I think it is the global institutions that have a very important role to play. And certainly at the World Federation, in partnership with CIP, this is your voice as engineers in Peru to get to the global stage and speak about what your view is about solutions and to make those solutions a reality.
¿Cuál sería la respuesta de la ingeniería civil para enfrentar el COVID-19 en futuras generaciones que no afecte el sistema laboral? ¿Cuáles serían las estrategias que se podrían implementar para ese fin?
I think civil engineering, it works in different ways in terms of providing infrastructure for all the delivery of services. So that is going to change in an event like COVID-19, because the deliveries which are required, the infrastructure, the type of infrastructure that is required is going to be quite different, which is a typical civil engineering course does not teach us. So a future civil engineer has to keep in mind how do the different systems work together. To give an example, does the COVID-19 did contaminate water or did it? We don't know. There is some indication that it contaminated water, and that's going to be a major disaster. So things like that, which we don't really learn in a typical civil engineering scenario, we need to be aware of that this is the unintended impact which could happen to the utilities. It could happen to the way we travel on the surface transportation. There are going to be more robotics. There's going to be more non-contact information. There is going to be so much information, as Gonke had said, which is generated, and we need to big data. But all of those things, which are all civil engineering related questions, surface transportation, air transportation, public transportation, how we design spaces, how we design office buildings, in the air conditioning, heating, ventilation system, is it going to transmit that? Is it a transmitter? So all of those issues are going to be very, very important. So the civil engineering is going to change in terms of how do we respond, because we need to really think again in a very comprehensive way. I think I will leave it at that, because there are many, many other aspects of the civil engineering can be impacted and can respond.
Primero que nada y sobre todo agradecer a nuestros tres invitados, al profesor Gonke, al doctor Muyundar y a la doctora Kanga, porque realmente le han dado mucho valor a este evento y lo que han podido aportar, las ideas fundamentales, ayudan a aclarar muchísimo la visión sobre el mundo, sobre el futuro, sobre la vida, desde distintos ángulos, con la especial característica de que son complementarios y todos en la misma dirección. Entonces, creo que dentro de los temas especiales, todos hemos coincidido que va a haber un mundo diferente. Todos hemos coincidido en la necesidad del conocimiento global, de la cooperación internacional, de la cooperación, entre expertos, porque esa es una de las formas de lograr el desarrollo. Creo que todos también hemos coincidido en la necesidad de los temas ambientales y en la sostenibilidad del desarrollo. Y quería también agradecer a aquellos que nos han seguido a través de estos medios, pero muy en especial al primer vicepresidente del Congreso, porque gracias a él, este evento ha sido transmitido también a través de la red del Congreso de la República, que además entiendo que se repite en otras ocasiones, llega a todo el país, se transmite también por televisión. Pero para mí el objetivo principal de tener una transmisión a través del Congreso de la República es que temas como los que se han conversado hoy en día han podido, en un lenguaje sencillo, en un lenguaje que está al alcance de todos, que permite a todos comprenderlo. Siempre he dicho que quien conoce algo lo puede decir. Entonces, a través de ese lenguaje sencillo pero profundo al mismo tiempo en significado, en proyecciones, ojalá que muchos de los congresistas que nos puedan haber escuchado les haya servido a ellos esto también para nutrirse de ideas, porque finalmente los esfuerzos de las distintas profesiones, de los distintos actores de la sociedad para poderse materializar pasan por las decisiones de gobierno. Entonces, creo que ha sido también interesante y provechoso que hayan podido ser escuchados en ese nivel. ¿Qué es lo que desearía? Que en el futuro volvamos a tener algunas otras conversaciones o algunas otras reuniones como las que hemos tenido hoy en día. Para nosotros en Lima es todavía el lunes 8 de junio, día del Colegio de Ingenieros. Con Vilas compartimos la fecha, aunque no la hora, pero entiendo que con Marlene y con Gonque, para ellos es el martes 9 de junio. Entonces, curiosamente, y por supuesto esto sin ningún valor científico, sino solo valor anecdótico, ellos han viajado un día al pasado para poder estar con nosotros en un 8 de junio. Nuevamente, un muy cordial, un cálido abrazo. Espero que volverán los tiempos, estoy seguro que volverán los tiempos en que podremos apretar las manos y darnos un abrazo. Y mientras tanto, les agradezco enormemente a nombre del Perú, a nombre del Colegio de Ingenieros, y también les transmito que el Colegio de Ingenieros siempre se seguirá apoyando a la UEFEO porque cree también en una ingeniería universal y que así como la ciencia éticamente es neutra, la aplicación de la ciencia que viene a ser la ingeniería no es neutra y entonces necesita normas que la regulen, que la orienten, que la guíen, en que todas las personas a su mejor comprensión y en los mismos niveles de cultura podamos dar propuestas a la humanidad. Muchísimas gracias, sobre todo deseando que volvamos a tener, y seguramente lo tendremos, una próxima ocasión. Muchas gracias y desde Lima, muy buenas noches con todos.
Somos el Colegio de Ingenieros, somos constructores del Perú, trabajando juntos lograremos desarrollo y paz en el Perú. Trabajando juntos lograremos desarrollo y paz en el Perú.